On behalf of Bacharach, the entire Bacharach team, I wanted to welcome everybody to the webinar. What is EPA Section 608 and what you need to know? My name is Donald Clark. I'm the Global Marketing Manager here at Bacharach, and just want to thank everybody for taking the time to join us today. I wanted to introduce our presenter today, Jason Ayers. He is our Connected Solutions Manager. Jason has been helping refrigeration system owners and contractors identify the leaks and reduce energy consumption for over 25 years. So he's worked across several industries, both in the UK and in the US. So we're thrilled to have Jason on our team, and he brings a wealth of knowledge and experience. And I'm sure that you're going to glean a lot of information through his presentation today. So with that, I will pass it over to Jason and we can get started.
Thank you, Donald. And hello all and welcome to today. Donald, just checking you can hear me okay?
Yes.
Thank you, sir. Okay. Hello all and welcome to today's webinar. We've got a lot of good content to run through with you today. So we will kickstart this. We've got information on EPA 608, really reconfirming to the three stakeholders, technicians, refrigerant sellers and equipment owners, what does it mean for you? What do you need to do to ensure compliance under 608? Also, for all those stakeholders, what tools are available to you to help you navigate through that compliance journey and look to manage and reduce your refrigerant usage? And then what's on the horizon? I did a presentation on this about 12 months ago. A lot of things have changed in the last 12 months. There's been a new president that's come on board and new regulations that are coming in place to look at HFC refrigerant. So we will touch on those as well to give you our input and thoughts on where the industry is going to go there. But first of all, let's start off with the Clean Air Act and EPA 608. The Clean Air Act is a United States law which limits national air pollution. To be honest, it's been one of the most successful US laws and influence in modern times. And it's a very comprehensive air quality law and one of the best in the world. In terms of EPA 608, it's targeting refrigerants and those emissions to the atmosphere. Really, its pillars are looking at prohibiting the release of refrigerant. So that's in the terms of maintenance, repair, new system, and also really targets the proper refrigerant management of the system. So the recording, the capturing of the information and having that information available to the EPA in case of any auditing. It really does focus on leak prevention and record keeping, and they are the really fundamental pillars of the 608. So what is covered and what is not covered? Before we go into the stakeholders of the technicians, the refrigerant sellers and equipment owners in more detail, let's be clear of where 608 currently lies in terms of the refrigerant. First of all, the assets or the appliances that we're talking about. We're solely talking about appliances with 50 pounds or greater of a refrigerant charge in them. So that's number one. Number two, the type of refrigerant as well that falls under EPA 608. Historically, it was around ozone depletion refrigerants, so that was aligning with the Montreal Protocol. So you'll hear the terminology class 1 and class 2. They're in essence CFCs and HCFCs. So if you've got appliances that are greater than 50 pounds with a CFC or HFC refrigerant, it falls under 608. What's also been added to 608 in terms of capturing the information is HFCs as well, or what we term the substitute refrigerants. So they are the equipment that you need to be aware of within your organizations. If you do have those types of assets and equipment, you need to be aware of that, and there's some reporting requirements under EPA. But what's not covered? Very simply, everything else. We've got lots of new refrigerants coming on the market that's used out there. So natural refrigerants are currently not covered. So the likes of ammonia, carbon dioxide, and hydrocarbons as well, propane, for example. These are kind of the typical refrigerants that you may run into in terms of your organizations. So in terms of the stakeholders, what are your specific requirements under EPA 608? So we're going to start with the technicians. These are the people who do the maintenance, the working, the repair, the disposal of equipment. So what do you need to do and what do you need to be? First of all, you need to be EPA certified before you can work on any piece of equipment. That certification is done through an EPA test center. Some of them are now online due to COVID. Some of them can be physically done at a premise, but you have to follow and take that EPA test before you can work on equipment. The tests fall into 4 categories. They're called Type 1, Type 2, Type 3, and Universal. Universal certification covers 1, 2, and 3. Simply, you can service, maintain, and work on any type of HVAC equipment out there. Type 1, Type 2, and 3 really focusing on more specific piece of equipment. So Type 1 is really targeted for technicians who may be looking at servicing small appliances, HVAC type equipment. Type 2 and Type 3 are more high and low pressure systems. So in your career or where you are in your journey as being a technician, it's important to identify and understand what type of certification you have, because it does dictate what type of equipment you can work on. If you're new to the trade, apprentices are currently exempt. So as long as you're under the guidance of an approved EPA certified technician, you can do work on that equipment. Certification is really the underpinning of HVAC technicians for EPA 608. As a technician, you're also obliged to provide information as well. So if you are doing work on equipment, especially for the appliances over £50, if you've added refrigerant, you need to provide information to the owner as an invoice of the amount of refrigerant added and the type as well. Also, if you've done any other repairs or inspections of that equipment as well, you need to apply that to the owner and operator as well. So there is some paperwork requirement out to the back of this that you need to provide. And again, it applies to these ozone depleting refrigerants, so class 1 and class 2. Even though EPA 608 is really focused on assets and appliances over £50, if you are disposing of appliances under £50 that have ozone depletion refrigerants, class 1 and class 2, and substitute, you as a technician need to keep those as well. So that's really a broad summary of what the technician's requirements are for EPA 608. The second stakeholder is the refrigerant sellers, the people who are selling that refrigerant to the technician that ultimately is going to use it on site. As a wholesaler, you need to keep records, and dependent if you sell online or in a physical location, you must keep those same records. And those records must be kept for 3 years. So it's important that however you hold them digitally or manually, they are available to the EPA if they came and asked for those records to be looked at. As a wholesaler, when you sell refrigerant to a technician, they must be EPA certified. So that's one of the criteria you need to be comfortable with. And that could be as simple as just looking at their certificate. Also, the type of refrigerant that you're selling to them must match their certification level. So if they're a type 1 only certified technician, there only be certain refrigerants that they can buy. Again, these rules and regulations apply to class 1 and class 2, as well as substitute refrigerants as well. And those refrigerants can be sold in cylinders, cans, or drums. Again, the wholesaler must be, when they're selling it to the technician, they be classes of all those receptacles as well. What it doesn't cover is refrigeration air conditioning equipment that contains or components of refrigerants. So it's really more the gas that's being sold. As a wholesaler as well as verifying the certification of the technician, you can also sell that refrigerant or have it transported not directly by the technician. So if you as a wholesaler are selling refrigerant, as long as you're comfortable that the end goal or the location of that refrigerant is going to be with a technician who has an EPA certified car or the company that's buying it has a EPA approved technician working for them, they can transport it on their behalf. As I touched on at the start, record keeping is very important under EPA 608, and for the refrigerant wholesalers and sellers, you must keep records for 3 years and have these available. Again, there's some critical information that needs to be held. First of all, it should be an invoice saying who you sold it to, when you sold it, and the quantity and the amount of refrigerant that's sold. Again, this could be for online sales as well as physical sales within your location. Certain types of canisters and small systems are exempt from the regulations, especially in the motor vehicle industry as well. So now we move on to the third stakeholder under EPA 608. We talked briefly about the technicians, the people who sell the refrigerant. The third area is the equipment owners or operators, the people with the refrigeration and HVAC equipment within their estate. The requirements under EPA 608 are quite extensive. We've got a couple of slides to run through here to make you aware of what your requirements are. Again, a bit like the refrigerant sellers, you must keep these records for 3 years. So with all the information that's captured, having either a digital system or even a manual system is perfectly adequate. It just needs to be a very simple system for you to provide the information. So what do you need to have? What do you need to have available and capture? First of all the appliance and asset details need to be captured. So make, model, serial number, equipment name, date it was installed, the amount of refrigerant in the system, and the refrigerant type as a minimum needs to be captured and available. Again, just to clarify, EPA 608 is just solely focused on equipment that's got over 50 pounds of refrigerant, and obviously class 1, class 2 and HFCs. That's the minimum that you have to have. If you have other equipment with carbon dioxide, ammonia, you may capture that, but there's no requirement to present that to the EPA. So as well as having the appliance and asset details, the other type of information is when any work is carried out on that equipment. And work could be adding refrigerant to the system. So that could be for a leak repair, a retrofit, or if refrigerant is being removed from the system, as you might be retiring that piece of equipment or doing a gas retrofit, you need to have records held for that type of process. The leak inspections, and we'll come on to that in next couple of slides. These are checks that you have to do on the system. If you've breached a certain leak rate, you have to capture that and have that available as well. EPA fundamental underpinning is about refrigerant management, containing leaks and reducing leaks. So if you do have a leak, you have to do verification checks afterwards, an initial and a follow-up verification. Again, as part of that process, you need to capture that information and have that available. With all these processes, the people who do the work on your systems, the technician, must be EPA certified. So and that certification level must match the type of equipment that they're going to be working on. We touched on that earlier about what a technician can do. So if they are doing work on the site, you need to capture their name and their certification level. If you have automatic leak detection systems on site, you need to capture that information as well. So the type of equipment there, the type of leak detection equipment, and also any annual checks that are done on it as well, those records need to be held as well. With that asset, if you're going to do any retrofit or retirement, and retirement, I mean remove it out of service, you need to capture that information. And that could be a plan, a detail. Again, records need to be held and available to the EPA. Other types of processes and reports that need to be held, extensions to any repair deadlines, you need to have those available. Systems that are mothballed, so that could be a chiller that you have that you don't use all the time, then you remove that refrigerant from the system whilst it's not in use. That needs to be captured and available. Any seasonal variation, so You may be adding or removing refrigerant at certain times of the year for the in-train charge of the system to help its operation. Again, that needs to be documented and captured as well. So you'll see there is a lot of information that needs to be captured and available to the EPA for a minimum of 3 years. All that information I've just touched on there is not required to be issued on an annual basis. It's more has to be available if the EPA auditor turns up to your site and asks for your records. So bear that in mind when you're looking at your particular enterprise or particular site or assets. One of the big changes that came through from the EPA a couple of years ago was the requirement to produce a report to the EPA at the end of the calendar year. That's probably one of the biggest changes in terms of reporting to the EPA on an annual basis. But it's not all the equipment. It only applies to equipment that has class 1 and class 2 refrigerants in there, so they're ODP refrigerants. And it's regarding high leakage of that equipment in a calendar year. And a calendar year is 1st of January to 31st of December. So if you have a refrigerant, HVAC appliance that's got more than 50 pounds of refrigerant, that's used over 125% of its charge, so simple maths, it's got 100 pounds in it, and in that calendar year it used 125 pounds of refrigerant added back to it, you have to report that to the EPA within 2 months of the following calendar year. So bear that in mind when you're looking at the assets that you've got in your system. If you've got some of these older ones with older refrigerants in there, there is a requirement to provide that a report to the EPA. So that's running through what you need to capture at a very high level. The EPA is all about, and 608 is about leak repairs and leak reduction. And you'll hear this word leak rates. Let's define what that means. A leak rate is a percentage of the total amount of refrigerant that's leaked out in 12 months, or leaked out or added back into the system. So I'll use the analogy I just said before. You have a refrigeration system with 100 pounds of refrigerant in. You add 50 pounds in a 12-month period, that system would have a 50% leak rate. And it's important that you understand how the leak rate is calculated, because it's a pivotal and defining element of the EPA reporting. And also under EPA 608, you must define the calculation method. So what I mean by the calculation method is are you using a 12-month rolling average to define that leakage rate, or an annualized? So an annualized would be a fixed period of time. A rolling leak rate is a moving 12-month rate. However you report that leak rate, you must pick one of those methods, the annualized or rolling average, under your organization, and stick to it. Most people we deal with use the rolling average leak rate to calculate their current leak rate of the system. And every time you add refrigerant to the system, you must calculate that leak rate at that point in time. Because if you have a high leak rate, or it goes above what we term a trigger rate, I'll touch on that in a second, you have to then follow up with additional corrective actions to identify and try and ensure that any further refrigerant losses are mitigated. So what do we mean by a trigger rate? So a trigger rate is basically a level that if you go over it, so that's a percentage of your leak rate, you have to do additional checks on the system, and they're called leak inspections. The chart on the screen here has different sectors. So the appliances that you have, and HVAC and our assets in your organization, fall into one of 4 categories. They are either for industrial refrigeration, commercial refrigeration, comfort cooling, or what we term other appliances. So when you're setting up your asset database, you have to define what category they fall into. So a refrigeration rack would fall under commercial refrigeration. A large chiller may fall under the industrial refrigeration. A HVAC asset, seasons 4, that's on a roof, would fall under comfort cooling. You have to put those into the categories, because dependent on what category the asset falls under dictates its trigger rate. So what we have here, the blue line is the older trigger rates, the green line, the green bars are for those assets, the current trigger rates. And you'll see they've come down. What the EPA are looking at is ensuring that we detect and report on leaking refrigerant sooner. So if you had a refrigeration rack that had 100 pounds of refrigerant in, and it lost 50 pounds of refrigerant in a 12-month period, it would have a leak rate of 50%. It would fall under the commercial refrigeration bracket on the chart there. And because the trigger rate is 20%, any percentage that's over and above that would mean that you have to do additional checks on that system, which we term leak inspections. So it's important you understand your assets, the grouping that they fall in under, and then when you add refrigerant to the system due to refrigerant loss, if they breach a trigger rate, you need to do something to follow up on that to prevent any further refrigerant emissions. And they're called leak inspections. So what is a leak inspection? Leak inspection is very simply a check on the system for checking it for leaks. And that's the entire system. So if you've got an asset that now falls under the leak inspection criteria, you have to do additional checks on that equipment. And those checks vary from every 3 months to a calendar month, depending on 2 criteria. One, the equipment bracket that it falls under, and the amount of refrigerant that system holds. Not how much it's lost, but how much it's holds. So let's use a refrigeration rack again. Say it's got 1,000 pounds of R22 on there, and we lost all that refrigerant in a year. It would fall under the requirement for a leak inspection. So it would be classed as commercial refrigeration. Its full charge would be £500. So under the EPA regulations, you have to do additional leak inspections every 3 months on that equipment. So somebody physically go to site and check all the accessible pipework with a leak detection system until you are satisfied that that leak rate is coming down and has gone below the trigger point. So be aware of that. If you use refrigerant, leak inspections are a requirement. You must document that you've carried out those leak inspections and have those available. One of the benefits of having an automatic leak detection system on those sites eliminates the need for those physical leak inspections. So if you have a leak detection system that's covering part or whole or the entire refrigeration system, you don't physically need to go to site to do those inspections. That automatic leak detection system that's looking for the leaks mitigates that requirement. But again, you need to capture it, you need to be aware of it, and you need to record it. So after all that, what if you can't reduce your leakage rate? What are the EPA asking for that side? Okay, you need to come up with a plan, and you need to create that plan within 30 days being above the leak rate. So what could that be? You might have a very old piece of equipment. Whatever you do, it's still going to leak a large amount of refrigerant. It could be old, it could be porous, there could be other technical challenges as well. So the EPA is saying, okay, you can't keep that leakage rate down just by doing the additional leak inspections. What else can you do? And it really falls into 2 areas. Either retire the piece of equipment, i.e. remove it and take it out of service, or retrofit the refrigerant in that system. The plan has to contain some key details, the appliance details, what the new gas is going to be, the records of removing that gas, and the plan if retiring it, when, and what that equipment is going to be replaced by. Once you've got that plan, you've got a year to enact it. So as long as you complete the replacement of that equipment or the retrofit the gas, if you're going to do that instead, you've got a year to do that. If you're going to retrofit the equipment, so take out the original gas and replace it with a new gas, and as part of that, I'm sure it's that journey to reduce to a lower GWP refrigerant. You also need to make sure that you repair all the leaks on that system as well at the same time as replacing that refrigerant. So it's not just a refrigerant change, it's also doing all those good things to ensure that the refrigerant doesn't leak out afterwards. There is options to request relief to the retrofit or retirement program within a 180-day window, which could then mitigate you actually having to enact that plan. But what it does mean is you need to have a good system to capture that information. You need to be aware of your requirements. You need to be aware of what leakage rates are and capturing that. You need to be aware that you need to keep inspections. And if you can't keep that reduction level down, you need to come up with a plan to stop any further leakage. That's really the fundamentals for being an owner operator of the system. So it's quite onerous, but there is help available for you out there. There are tools available for equipment and owners and contractors to help them navigate their refrigerant management journey. We're not all experts in compliance, and it can be a complicated process, and with rules changing all the time with individual states and new regulations coming in, it can be very difficult to keep on top of that. Bacharach have solutions that can help you navigate that refrigerant management journey, compliance requirements. We have a variety of refrigerant tracking suites where you can capture all that asset information, capture all centrally the usage information, ensure that you're compliant with regulations, and utilize that data to help your refrigerant reduction strategies, as well as software solutions to help EPA compliance. There's also availability of technologies, including leak detection, to help reduce and mitigate refrigerant loss as well. The whole aim is we want to keep refrigerant in the systems. These systems leak. It's the nature of what we have with the design of refrigeration. But how can we get to those sooner? How can we utilize the technologies that we have available to detect leaks sooner, repair them sooner, and reduce refrigerant loss through early leak detection? And that does really lead into the definition of gas detection. There are two ways of looking at gas detection. There is safety compliance and there is leak detection. Just want to spend a short while just to clarify the difference, because it's extremely important if you're looking at a detection system to help you reduce your refrigerant usage and be ahead of the game and look at EPA 608 compliance. First of all, we have safety gas detection, ASHRAE 15, EN 6378 in Europe. This is really about protecting the personnel in a space. It's gross leak detection. It will tell you you've got a refrigerant emission at a very high level, and it will allow you to evacuate the area and protect people. Unfortunately, once you're detecting refrigerant at that high level, which we're talking the 800 to 1000 ppm, these are kind of the exposure limits and the safety regulations. You've got a large refrigerant loss. You're at the wrong end of the curve. Okay, yes, you're protecting the people, but are you getting to a point of reducing the refrigerant loss? Where can you go from there? The other side is leak detection. So this is turning the sorts of leaks on their head and the detection systems that you've got. The technologies are available now can go much lower in the detection range of picking up refrigerant in the air. Ranges from 1 to 100 parts per million is what we term early leak detection, early warning to potential large refrigerant losses. That's what we term leak detection. If you look and respond to leaks in that area and that range, you will reduce your refrigerant usage. You won't eliminate it completely, but you'll certainly help reduce your refrigerant loss, find more leaks, find more small leaks, and help your overall leak detection strategy. So as well as safety compliance and moving to better deployment and leak detection, how else can you improve your leak detection within your facility? Improve the number of sample points. If you're looking at purely safety leak detection, you might have one sensor just on the wall in a large chiller room that will detect a high refrigerant emission, which is great for safety protection, but it doesn't help you reduce your overall refrigerant loss. First area is increase the number of potential sample locations, or where you can pick up refrigerant leaks. The more sample points you have, the more opportunities you have to detect refrigerant leaks earlier. It is a sliding scale. You can't just put hundreds of sensors in there, but the more that you have, the quicker that you can respond to that refrigerant leak and reduce your refrigerant loss sooner. As well as more sample points, moving those sample locations closer to the potential leak source goes hand in hand with that as well. So if they were on the wall before, move them closer to where those leak points are, onto the chiller, onto the refrigeration rack, within a walk-in cooler, close to those changes in pressure and temperature where the common leaks occur. Closer to the leak point means you'll detect the refrigerant earlier, you'll detect it sooner. And finally, detecting it at a lower ppm level. If you're detecting it in the hundreds of ppm, you're going to be at a point where you've got a significant refrigerant loss, and also it's going to start impacting on the operation of the system. Having the right technology and a low level leak detection level all the way down to 1 ppm allows you to transform your look and view of leaks. Get to them sooner, get to them closer, and keep those that refrigerant as much as possible contained within the system. So we've gone through a lot so far. We talked about EPA 608. What does that mean for refrigerant sellers, technicians, and equipment owners, and also some of the technologies that are available to you to help on your refrigerant management journey. The next area that's been in the headlines very recently is the AIM Act, and I'm just going to touch on that and what that could mean to you as people within the industry, people who maintain, support, supply refrigerants. The AIM Act is focused on HFC refrigerants, and it's really focused on reducing the availability of them onto the US market over a 15-year period. If you're aware of regulations in Europe with the F-gas regulations, it follows something similar to that. It's to reduce the overall GWP or tons of refrigerant that could be emitted into the atmosphere. It's not looking at reducing raw pounds of refrigerant, but guiding the industry into using refrigerants that have a lower GWP. That could be HFC refrigerants, new refrigerants that are on the market now, or their substitutes in the future. And it's looking to phase down the production, so the availability, and also the consumption of HFCs. The AIM Act is also to help companies transition to new generation technologies as well. The answers to these aren't necessarily here and now, but those technologies are available. Natural refrigerants, CO2, A2L refrigerants, low GWP are all starting to become commercially available to organisations that will fall and help on this journey to as HFCs get reduced in the marketplace. So what is this going to look like? Now, all of this is being discussed at the moment, so this is not cast in stone 100%. It may change slightly, but the overall strategy is a 15-year reduction based on baseline usage of 2020 consumption. From 2020 to 2022, we have a 15-year step down on the production and consumption of refrigerant that's available to US consumers. And it's on the metric tons of the refrigerant, it's CO2e. So it's not about the physical amount of refrigerant, it's that amount of refrigerant and its CO2 equivalent. So it's guiding consumers, equipment manufacturers, and people who are potentially going to look to buy refrigerant to using lower GWP alternatives out there. Again, that could be still a HFC, or it could move you to HFOs or natural refrigerants. And this is a 15-year program, so it gives time for the industry to recognise and to plan for those transitions. There is a step down. They come down in step downs. First 2 years, the production level is looking only at 10% reduction on whatever the baseline that's going to be agreed. After 2 years, there is a significant step down, around 20 to 30% that's going to be available on the market. So that will start to create potential supply and demand issues, or start to guide people to look at low GWP refrigerants. And you can see this step down. There's two significant step downs in the early stages in the first 8 to 10 years, and then it lowers out at the bottom. Why is the US doing this? Part of the Kigali Agreement and the US committing to that now is to reduce CO2 in the atmosphere and obviously temperature rise. So the American and US system is aligning, becoming a leader in reduction of GWP refrigerants on the marketplace. And again, it's targeting those HFC refrigerants, and it's about supply, demand, and consumption. What does it mean for you? Be aware. Be aware of, if you're looking to buy equipment now, what could it be? The table here is the refrigerants that fall under the AIM Act, but they are blended together to the refrigerants that you know and love today. The 404As, the 448As, the 410As, and the HFC applications. All of these are going to be affected by this phase down in one form or another. The main ones are going to be affected are the higher GWPs. They will become less available on the marketplace for consumption and production. There are trading schemes that are going to be available, and that is part of the AIM Act as well. But bear that in mind when you're looking at your refrigerants of choices in the future. Looking towards a lower GWP will help you stay ahead of the phase down. And we've seen this already. We've seen this in Europe. The F-gas regulations that have been enacted much earlier was all about the HFCs and CO2 equivalent on the marketplace. And what did it do? Well, when we had those step downs in Europe, it had a dramatic effect on price of refrigerant. The chart that's on here is one that you might have seen before, and it shows the common high GWP refrigerants that you know: 404A, 410, 407C, 134A, the commercial chiller type application HFC refrigerants. You'll see a massive upsurge in price. So percentages up on the left side, it's not raw price, but you can see around late 2016, early 2017, a huge price increase in these refrigerants. And this was all about the availability of them on the marketplace. With the step down in the amount of refrigerant on the marketplace, refrigerant manufacturers are there to sell raw pounds of refrigerant. So they started to reduce back 404A and bring in lower GWP alternatives. So that drove supply and demand. Also, people were worried about keeping their existing systems up to date. So there were huge price increases. Those prices have come down over time, but they're still much higher than they were 10 years ago. So what does that mean? Containment is really important. Identifying and keeping refrigerant loss to a minimum, not just to protect the environment, but there could be a huge financial burden as well as part of the organisation. So what does this impact mean on refrigeration? Well, there's going to be a reduction in HFC supply and consumption over the next 15 years. Understand that, be aware of that. There'll be more tracking systems, electronic and reporting requirements for the movement of HFCs. And this could be from their production, the tracking of the cylinder, and the tracking of that gas throughout its life cycle of where it goes into the system. Under the AIM Act as well, they're looking to ban disposable containers as well, and looking just to move to refillable containers. So something to be aware of as well. Everything that's going to be looked at is going to have an administrative consequence. You're going to have to do more work. You're going to have to be aware of the regulations, and also there's going to be enforcements that are going to follow that could have civil criminal penalties as well. So being aware of what's required, keeping that information up to date, reporting that is key. And it really comes down to that record keeping. Reporting, auditing, data transparency is a key element of the AIM Act as well. You hear it on the EPA 608, they require that you keep this information, have it available this is going to take it to another level out the back of that. So be aware, understand what you may need to do within your organizations to be ahead of the curve. But there are ways of obviously reducing your HFC consumption, and everything has to be looked at in the right mindset. Where you are in your organization, what are your goals, what's your sustainability, and also cost is a huge driver out of that. And there's ways of looking at, there's long-term strategies. These are the cost exercises. This is looking at refrigeration plants and capital replacement. That's a great way of reducing refrigerant usage and allowing you to move to next generation technologies and lower GWP refrigerant. But it's costly, it needs to be planned, and it doesn't fit with all our organizations at that same point in time. There is a middle ground, moving to alternative refrigerants. And for this scenario, we'll talk about drop-ins. So keeping that existing plant operational, but replacing that high GWP refrigerant with a lower GWP alternative that will still allow it to operate in its same conditions, same pressures, temperatures, and also with the energy envelope as well. Like with anything we're doing to reduce our GWP footprint, refrigerants is one side of that, but it's not the whole picture. We need to be looking at energy as well. If we're looking at new systems or new refrigerants that will reduce their GWP emissions through leakage, but they double the energy, is that the right technology that we should be looking at holistically as an industry and as a company as well? But drop-ins allow you a lower cost option to help on your refrigerant GWP reduction, and also with having the refrigerant available as well. But also there's other lower cost options that are available here and now. That's around leak detection. Technologies that you can add to systems now that will help reduce and mitigate refrigerant loss, keeping that refrigerant in the system, identifying quickly and timely when refrigerants are coming out so you can make repairs, and keeping costs to a minimum. If you start with that side of the spectrum of leak detection, anything you do above that is going to just reap rewards. So how can Bacharach help with this approach to refrigerant management and refrigerant reduction? Well, if you want to have a fully connected solution and look at being a leader in sustainability and have a very achievable leak rate of under 10%, you can do that. And it forms under 3 areas. First of all, it's having the right types of technology out there, the right type of leak detection that can detect down to the 1 ppm level, and that equipment deployed correctly within your estate. That will give you the foundations to detect refrigerant sooner. Those equipments work great on their own. How can we elevate that detector and that information? Connectivity is key to that, allowing you to retrieve that information and using the data proactively within your enterprises to see and be aware of leaks sooner, allow you to manage your engineering teams better, allow you to direct them better to the source of the problems. Data-driven systems and solutions provide part of that overall solution. And also alarm and response as well. We talk about going down and being able to detect to 1 ppm, but it's also looking at the alarm set points. Okay. Traditionally, we've been looking at alarms around the 2, 3, 4, 5,000 ppm. If we're responding at that level, we have a sizable refrigerant leak. Let's look at that and moving that lower, looking at the 5, 10, 20 ppm to a response to an alarm. We're not saying that at that level you should be rolling trucks, but at that point you should put a works order in and have somebody attend site to try and investigate and find these small habitual leaks before they get bigger. At that level, you will be able to locate them, but they will need to take a little bit more time. But it's all a part of this strategy to reduce your refrigerant usage. And in terms of the technologies that are available, Bacharach multi-zone gas detector is probably the best in class system out there for low-level leak detection. Has some key benefits for you as an organization for detecting refrigerant. It can be used in any environment. So it doesn't matter if it's cold or hot. The sample location of the detection of that leak, it can work in all those areas. We talked about detection points earlier. The more detection points we have, the closer to the leaks, the better and quicker that we can respond to alarm. The aspirated multi-zone system allows you to deploy more points of detection much more cost effectively and much cheaper. It has a broad detection range, so we can detect that down at those low level ppms. We can see leaks earlier, but we also have the ability to alarm at those higher ranges for safety compliance as well. So you can get safety compliance and low level leak detection in one solution. The technology in the solution is very low cost of maintenance, so the life cycle costs, like with any system, should be taken into account. The equipment, the technology, the sensor lasts for multiple years, so you're not having to replace systems on an annual basis. It gives you a very low cost of ownership. And with a continuous calibration, it allows it to detect low level ppms. It keeps that sensor accurate and response to alarms. And with other technologies that are non-infrared, they can get depleted and affect their sensitivity when they're exposed to refrigerants or other gases in the area. Using an infrared technology mitigates all of that. So you've got a technology that's going to be stable and accurate for years and years. And with any of that technology in the Bacharach multi-zone, the deployment of it is key. The enunciation and connecting it to local systems, beacon sounders and local BMS systems is important, but also then connecting it to an IoT platform, elevating that data out the back of that, using that data to respond and be more proactive in responding to leaks. And that's where data analytics come in. The PowerSense platform that's been designed and developed by Bacharach allows enterprises to manage their refrigerant leak detection alarm information much better. They can see holistically what's going on, which is my worst site for alarms, which is my most problematic site for alarm. Where do I need to target and utilize my maintenance resources to reduce refrigerant usage? And where should I focus on? Should I be focusing on the high critical alarms, which are very rare? Or should I be focusing more now on the early action, this low level range, the alert and the alarm area, this under 100 ppm? Just an example of the graph here is something that we see time and time again in our Connected Solutions Bureau. We see refrigerant leaks start early and at small levels and go on for continual periods of time. These could be hours, days, or even months. At these levels, you will not see a loss of refrigerant. You won't see a system performance issue. You won't see an energy issue. But if you were to respond to these alarms much sooner, you would avoid any long-term higher refrigerant losses and reduce your overall leakage rate. So it's utilizing the technology and the data and being more efficient and effective within your organizations. And these types of systems are available now. They're available for you as users on the marketplace. And finally, hardware, the right type of equipment, connecting that equipment and utilizing that data proactively. And the third element is a comprehensive refrigerant tracking and compliance software. Again, Bacharach have a comprehensive and award-winning suite that can help support that as part of your EPA 608 compliance journey, or as a part of a wider refrigerant management understanding, where you can add the assets, the appliance, the sites, technicians, record the information, understand compliance, and ensure that if you ever get audited by the EPA, you have a one-stop solution that you can provide that information to the associated authority, but also not having to understand the complexities of compliance and having the system guide you through that journey. And also it can be built into workflow systems to help data capture there. So there's a lot that I've been through today talking about EPA 608. The tools are available to you. Some of the elements that are on the horizon for HFCs and some of the solutions that Bacharach have available to you. And as all an organisation, Bacharach here are here to safeguard people, places, and the planet. I hope you found that useful. I'll open up the audience and see if there's any questions, Donald.
Yeah, absolutely. Thank you very much, Jason. I appreciate all the information. I'm sure everybody else does. So at this time, we will open it up to some questions. We do still have some time left. So if you wanted to continue to type anything in, feel free to, or you can use the raise your hand feature at the bottom. I will see that. I will unmute you and you can chime in and ask Jason any questions. For additional resources, if anybody is looking for more, I am sending this over into the chat right now, a link to our resources on our website. This will include some videos, some of our past webinars, as well as some white papers. So that's available there. And Jason, we did have a question that came in earlier that I wanted to touch base on. And this is referencing the table on slide 11. There was a question about the 50-pound trigger rates and whether that was speaking specifically to each individual piece of equipment or the collective units of equipment at a facility.
Okay, let me, so the trigger rates that are applied are at the asset level. Okay, so if you've got 5 racks on site and they've got 100 pounds on it, you don't add them all together. The trigger rates that are applied are at the asset level. So you don't, there's no adding of these together to get your overall refrigerant consumption, and then the amount of refrigerant, these are done on the asset level. So think of it of that. Every piece of equipment that has refrigerant in, it falls under this trigger rate calculation. So that could be a rack with all the connected features together, that is deemed as one system. You might have a chiller over here, that's deemed as one system, but you don't add those numbers together to give your collective entrained volume leakage rate out the back of that. I hope that makes sense.
Yep, that's clear. All right, let's see. We've got another question here from Nick. Are there any low GWP HFCs that will not be covered by AIM?
So that's a good question. Let me move forward to this slide, and I'm not going to be able to answer that question at the moment. So the way I see it at the moment, and I may not be 100% correct, but let's just give some guidance on that. The table that's on here, so take the orange bits to one side, I added those afterwards just for that. These are the 17 refrigerants or the single blends that fall under the AIM Act. So if they are part of a blend, they will probably most likely fall under the AIM Act because they form part of a constituent of an overall blend of refrigerant. So that's why I added those orange ones in there as well, because they could form part of that. If it's deemed an HFC, it's most likely going to fall under that. Hopefully I've answered that correctly or given you a steer in that direction.
Okay, great. Yep, and Nick, if you had any other follow-ups, yep, he said that was clear.
Thank you.
All right, so with nothing else coming through, I just want to thank everybody again for joining us, and thank you, Jason, for all the information. I hope that that everybody got something out of this today. And again, check your inboxes next week for a follow-up email for this, the recording of this webinar, so that you can reference that in the future, or feel free to share it.
Thank you all as well. Thank you for attending, and thank you, Donald, for putting on the webinar today. Much appreciated.
All right. Have a great day, everybody.